Today I am going to be explaining how to derive the time-dependent material and energy balances and how to stimulate the change in concentration and the change in temperature over time in a situation where we have 15 continuously stirred tank reactors and those tanks are in series with each other. So in our last problem we derived the time-dependent material and energy balance and we stimulated those two variables for a singular CSTR. So we're just going to build off of the code that we already have. So to start out, we need to initialize our value for n. So n is going to be the amount of reactors that we have, and we have 15. So then we also need to divide the volume by 15 so we can spread that volume over all 15 reactors. And we're going to do the same thing for our UA. So now we need to look at our initial concentration and our initial temperature. So we see that we only have one numerical value for these. And since we have 15 CSTRs, we need to create an array of 15 of this value. So we need to do np.full to create the array, and we are going to tell the code that we want 15 of these by saying n, since we already initialized n as 15. And then we need to do the same thing for our temperature, and then 350. We are also going to change our time down to 3 minutes. So now we can look at our CA naught and our T naught and see that we have an array of 15 0.5s for our concentration. And if we look at our T naught, we can see that we have 15 350s for our initial temperatures. So now we are ready to look at the right-hand side of our equation. So we know that Python wants our initial variable, or our independent variable, and then a vector of our dependent variables. But since our dependent variables are now in arrays, we need to do that same thing for our vectors. So we need to split these two up. So we are going to have EA is equal to the vector from our first CSTR to our last CSTR. So by using the colon and nothing in front of it, that just shows Python that we want to use the first value in our function. And also a thing to mention, so Python indexing, they start at 0 and then go to your final value. So this entire equation is going to be in the sense that our first CSTR is 0 and that our last CSTR is 14. So now we need to do the same thing for our temperature. So we're going to have our vector from our first CSTR to our last CSTR. And we are going to have our K equations stay the same, but our differential equations are going to change slightly. So we're going to have an equation for our first CSTR. And then we are also going to have equations for our remaining CSTRs. So this is going to be our CSTRs number 2 through number 15, or in Python indexing, our first CSTR through our 14th. So we are going to use the same equations that we used in our last problem, but we are going to say that this is our initial dCA dt and our initial dt dt. So we can see that our initial CA going in is going to stay the same since this is just going into our first CSTR. But now we need to specify that this concentration is the concentration of our first CSTR, and same with that concentration. And we need to tell it that our K is the first rate constant for these equations. So we're going to do the same thing for our temperature. So we're going to leave our TI as the same since that is our initial temperature going into our first CSTR. But we are going to tell the code that this temperature is our temperature inside of the first CSTR. Same with this temperature. And we need to do the same thing for our K value and for our initial concentration. So now to look at our remaining CSTRs, so I'm going to copy down these same equations. And now these are going to be our dCA dt and dt dt for all of the CSTRs except for the first one. So we know that our initial concentration going into each of these is coming out of the CSTR behind or in front of it. So we are going to say that our first CA is from our first CSTR, but we are going to exclude our last CSTR. And then for our other two concentrations in this formula, we are going to exclude our first CSTR and we are going to go to the last CSTR. And then for our concentration, we are going to do the same thing. So we are going to start from excluding our first CSTR, but including our last. And we need to do this exact same thing for our temperature. So our first temperature is going to include our first CSTR, but exclude our last. This temperature is going to exclude the first, but include the last. Same with this one, exclude the first, include the last. And then same for our K value, and same for our CA value. Okay, so now we need to combine our concentration equations and our temperature equations. So we are going to do that by using np.concat. So we need to do this since we need to have an array of all 15 of our final answers, and we're going to get 1 from our top equation and 14 from our bottom. So we need to do, or we also need to create an array. So we need to create the array for the concentration and the temperature, but we also need to create an array of the two of them together. So now we need to do np.r of our dCA dt naught, and then our dCA dt. And we also need to do the same thing for our temperature. So we're going to have dt dt naught and our dt dt. Okay, so now we're ready to use our solve IVP, but we also need to concatenate our arrays together here. Okay, so now we are ready to plot out our equations. So we can use the same t-plot, and we are going to change this down to 20 data points just for our beginning. And now we can do our result.sol of our t-plot. And now we should be able to look at the shape of this. Okay, so we can see that our shape is 30 by 20. So we know the 20 comes from the amount of data points that we have here. But since we have two equations in here for our CA and our T, it is actually giving us 30 values because it's giving us each value. And we have 15 for concentration and 15 for our T. So we can do reshape, and we want to break our first one into 2, and we're going to evaluate it through n, and then we need to have the same amount of data points. So we can see we have a lot of data points here. So if we look at the shape of this again, we can see that we now have 2 that have 15 and then 20. So we have our 15 reactors and then we have 20 data points. So we can set this equal to our CA and our T. And now we are ready to plot this out. So get rid of this. Oh, didn't mean to do that. What do I undo? Undo. Okay. So let's put in our figmake scatter plots. Now we need to have a scatter plot for our concentration and for our temperature. So we do need to change these slightly. So we need to have our y value is from, or no, actually, we need to make a for loop for these. So we're going to do for I in range of n. And this just creates a for loop that we can pull our variables from. So now we need to do our y values are equal to I using our for loop, and then we're going to do a colon showing that we want all of our values from 0 until 14, or in other words, our first CSTR through our 15th CSTR. And we need to do the same thing for our temperature. Oh, I did that wrong. I colon. Okay, and then so we also want to be able to name each of our lines as what CSTR they're coming from. So we need to use F, and then we need to tell it to pick the correct value of I. And we are going to do the same thing for our temperature. And now let's update the layout of our graphs. Let's see if this works. Alright, they look a little funky, so let me look through the code here and see what's going on. Okay, so actually our temperature needs to go from N until our final, so we're just using our final here. So let's run this again. Oop, I don't think I ran this. Okay, so now that looks a little better, so I'm actually going to make the width of this bigger so I can see what's going on. Okay, so we can see that on our concentration graph, if we zoom in here, we can see that it's very broken up. So this is probably because we don't have a lot of data points. So let's go back up here and change this to 500. Oop. Run this again. There we go, we're a little bit more smooth now. So if we look at this, we can see that our blue line is our CAO, so our first one, and then over here on the side it shows us the index in the colors of each of our reactors. So we can see that our concentration begins to increase, and then it begins to fall, and obviously the first CSTR is going to be more dramatic than the rest. But all of these CSTRs eventually reach almost 0, so we're at about, we reach about 0. So that means that our concentration is almost 0 at the end of our reaction, and that makes sense since we have a reaction going on, so the concentration of A is going to decrease as the reaction proceeds. And then we can also look at our temperature graph here, zoom in a little bit more. Okay, so we can see that all of our CSTRs start out at 350, and they all fluctuate up, and then they all reach a steady state again. Now, while the steady state between these is not exactly the same, they all do reach their own specific steady state. And like I was talking about with our concentration, we also reached a steady state between all 15 CSTRs. Thank you for watching.